So hey everyone, from today we are gonna discuss about some basic maths problems in A to Z series, and after completion of this series, you will be able to get a small basics like what modulus do and how we will be able to get rewards and Armstrongs and prime, all the things in easy manners. And I will be giving you the PDFs and the code in the description so you can check. So what this question, so the first we have modulus. So in C++, the modulus operators is used to find the remainder when one integer is divided by another. Okay, so we have like we this is the syntax like how we do modulus and store in result variable. So int result equal to a modulus of b. So a is dividend, b is divisor, and result the remainder of after division. So basically we have 1 2 3, we have modulus of 10. So when we divide 1 2 3 with the 10, like initially we will be getting 10, then 2 3, then 2 we will be getting 20, then remaining is 3. So this is the remainder. So the output is 3. So the output here is 3. So now we have example here. So 10 modulus of 3, we will be getting 1. So result is 1 because 10 is divided by 3 leaves remainder of 1. So this way we can do this. So we have important some points regarding modulus. Modulo can only be used with integers. So sign of the result is the same as the sign of the dividend. Okay. It's often used to determine divisibility. Example, if a modulus b equals 0, then a is divisible by b. So these operators commonly used in algorithms that require circular array checking for even odd number for handling wraparound scenario. So this is one of the most important thing. Like whenever we want to use wraparound scenario, we use modulus operator. So like there are dozen of lead code questions, and we have corpus questions where we require this wraparound scenario where we want to go from nth index to the first index. So we use kind of modulus functions or modulus operator. So we have the first problem which is called reverse of a number. Okay, reverse of a number. So we have this first problem. So basically what it does is passing n value, then okay, let's I will explain you with a small diagram. So initially reverse is equal to 0. So like when n is greater than 0. Okay, let's suppose we have 1 to 3, 1 to 3, reverse of this is 3 to 1. So like how we will get the output 3 to 1. So n is greater than 0. Okay, so like 1 to 3 is greater than 0, so it will go inside. Initially reverse is 0, so initially it is 0. So now reverse equal to revert in 10 plus n modulus 10. So reverse is initially 0, so this will be 0. So n modulus 10 we will be getting 3 value initially. Now n divided by 10. So 123 divided by 10 we will be getting like, okay, we will be getting 1 2. Okay, yeah, what 10 divided by 3. Okay, yeah, 1 2. So we have like 3 is there now. So 1 to 3 divided by 12, we will be getting 1 2. So 10, we will be getting 1 2. So now we have 1 2 here. 1 2 here, 1 2 is greater than 12 is greater than 0. So now into 10. So we have 3 initially, 3 into 10, 30 plus n modulus of 10, we will be getting 2. So we will be getting 32 now. And 32 and n divided by 10, to 12 divided by 10, we will be getting one value. Okay, 1. Now 32 into 10, we will be getting 320. 320 plus we will be getting n modulus of 10. N is 1, so n 1 modulus of 10 we will be getting 1, so 3 to 1. So 3, this way we will be getting the 3 to 1 value. Okay, so you can also try a dry run, so you can get the solution. So now we have like now count the number of digit, count the number of digit. So in this problem, what we gonna do here is, so we have 1 2 3. So divide by 10. What we will get? We will get 1 2. Now divide by 10. We will get 1. Now divide by 10. So we will not be able to go further this because the value of n is greater than 0, which is false here. We will be getting in some decimal value. So like 123 is divided by 10. Okay, initially we have 123. Okay, count is plus 1. So count is 1. Now divide by 10, we will be getting 12. Okay, now 12 is greater than 0. Count plus plus. So here we will be getting 2 and divided by 10. So we will be getting 1. So 1 is greater than 0. Here the condition is true here. 1 is greater than 0. Yeah, it is greater than count plus plus, so we'll be getting 3. So 1 divided by 10, which is in decimal value, so we'll be outputting 3. So return count 3, so we'll be getting count. So we have palindrome. So I don't need to explain it once again. Like we do in reverse of a value like 1 2 3, we will be reversing 3 to 1. Now when it comes like 1 to 1, and the reverse of this is 1 to 1. So we have actual number 1 to 1, and the reverse of this is 1 to 1. This is called palindrome. So simply we find the reverse number using this format, and we check if the original number equal reverse number. So if it is equal, then this is called palindrome, else it is not palindrome. So we have Armstrong number. Armstrong number are basically like if we do something cube, like okay, so let's suppose we have 1 to 1, and we like 1 into 1 into 1, and plus we use 2 into 2 into 2, and then plus 1 into 1 into 1. So which is equal to some value like 36, something like that. So we call it not Armstrong. But when it is equal to we have initially passes 321, and we got 321 as output, then this is called Armstrong number. So like 0 and 1 is called Armstrong number, and further there are much more Armstrong numbers, so you can check them. So like how we proceed it. So we need to like 1 2 3, we need to get 1 cube, 1 cube, 2 cube, plus 3 cube. So modulus, using modulus we can get the last digit. So we will calculate 3 into 3 into 3. Then we can get second last element, and we can add 2 into 2 into 2. Then we can add 1 into 1 into 1, and we can check, we can return if all number equals sum. If it is equal, then it means this is an Armstrong number. So you can check like this is not equal to palindrome. This is something like different. We use like we do some cubic operations for checking in Armstrong. Now we have print divisor. Like we have one to like we let's suppose we have given 12 value, 13 13 as our input. So like there are many numbers which is divisible by 13. Like okay, no, there are not. So here we will not getting anything. Like just we will be getting 1 and 3. 13 is itself is the divisor of 13. But when we will give our input as 12, so like we will be getting 1, then 2, then 3, then 4, something like that, dot dot. So and modulus 2 equal to 0, then C out of I. So we'll be getting is at our output. So now we have the second questions, which is same as this. So this is just an optimization of this approach. Like here if we check the complexity, time complexity, which is the equivalent to big of n, but now here it is reduces from big of n to like log of square root of n. Okay, so this will be the time complexity, like how we are getting these complexities. As you can see, it is going from 1 to n, but here it is going from 1 to square root of n. So if we'll input as 36, square root of 36, which is equal to 6. So as you can see, like 1 to 36, there are 36 number. It have to iterate in the above approach, but in this approach we have to iterate just 6 number. Okay, so this way we can find the divisor, and like we can do like how we are getting all the divisors. So and modulus of I, if it is equal to 0, so we will be outputting. Okay, so you know that why we are outputting this. But the second thing is, if I not equal to n by I, it means that like 36 we have one is divisor, yeah, and we have 2 is divisor, and we have 3 is divisor, dot dot, and like I will be putting the last value. 36 is also a divisor. Now 1 to 6 we can get this divisor, but how we can get 36? Using this n by I. So I not equal to n by I. Okay, so like 1 is not equal to 36 by I is 1, so which is equal to 36. So we will be outputting 36. So this way we will be outputting values like n by 2, which is like okay, we have like 36 by 2, we will be getting like 1 and 1 6 8 18. 18 is also there, something like that, we can get the output. So this way we can print all the divisor. So we have one more method to calculate all the divisors using some optimization. So we use like set operation. Why we are using set operation? In this above, like we are using these conditions, which is I not equal to n of I. Why you are using this? Because like 6 is 6 modulus of I equal 0, so it will be printing 6. But now if we don't use this, 6 by I, 36 by something like 6 is equal to 6. So again 6 will be stored, like 6 will be stored two times. But in this case 6 will be stored in one time, because this is the property of set data structure. This, it stores the unique values. So this is the iterator we use for iterating and printing the values. So basically, to remove that condition, we are using set data structure and inserting the value of I and n by I. So this way we can store it and use it. So we have one problem which is prime number. So in this case we are passing some value like 36. We are checking whether this is prime number or not. So basically we are iterating one loop. Then we will checking if n modulus of I equal 0. If it is equal, then we will checking if I of I and I is equal n. Then we will count, increasing the count plus plus, and else we are increasing count plus equal to 2. So at the end we will be checking if count equal to 2, then it is prime. As it is not prime, let's suppose we have 36. So like let's suppose we have 13. So like 1 2 and like 13, we will checking all the values to check whether this is divisible by 13 or not. If it is, then we will be printing it is prime. Else it is not prime. So we have one more math question which is called GCD. GCD, what it tells, like highest count factor. So like let's suppose we have 20 and we have 40. So the highest count factor is 20. So 20 will be the output. So uh, how we can this is slightly optimizations. Like what we are going here, we are iterating a loop from 1 to less than of minimum of a comma b. Why minimum of a comma b? Like 20 comma 40, the minimum value will be 20. So like it will go till 20, and we'll be checking if a modulus of I equal to 0 or b modulus of I equal to 0 simultaneously. If both are equal, then GCD will be initialized by I. So why 20, why not 40? Because like 20, we have to find the highest common factor between the two numbers. So one number, if it is like smaller than the other number, so the HCF should can't be greater than this the smaller number. So that's the reason we are like going till the minimum of a comma b. Or we can also do one more thing optimization. Like we can initialize I equal to minimum of a comma b, and we can go till I is less than equal to 0. I is greater than equal to 0 and I minus minus. So we can also do this. So like for the first loop, we'll be starting from here, and like it will print GCD of I equal to I. That's it. So we have like, okay, so this is the optimization I was talking about. So if it will got like 20 comma 40, initially it will get 20, and when it will get 20, it will break, and it will return the GCD value I minus 1, and then it will return the GCD. So we have one more method which is called Euclidean algorithm. So this way we can find the GCD in log of n times. How we can get the log of n times? So let's suppose we have 20 comma 40. So we'll be checking while b is greater than 0. So this is a, this is b, and which is true. So it will go like temp is equal to 20 modulus of 40. So we'll be getting like 20, and like temp will be 20, and then a equal to b, like the value of b is 40, and a will be getting 40 and b will be getting 20. So we have swap, and we will be returning the value of a. So at the end we will be returning the value of a. This way we can solve the problems, and in a log of n times. So we have one more problem which is called exponential problem. Here what it do, like we have to power 126. So it will calculate 126 to power 126 in a very small time. How it calculate it? Like let's suppose we have 2 to the power 12. Now let's see what it do. Like let's suppose x is 2 and we have n is 12. Now we'll be initializing answer is equal to 1, and we know that n 12 is greater than 0. So n modulus of 2 will be getting like if it is equal 1. So like it is not equal to 1. So we will go on the below. So in below, what it does is like x into equal to x. So like we have x2, so it will be storing like 4, x is equal to 4. Now n divided by equal to 2. So we'll be getting like 6. Now we have 6. Again, we will checking n plus 2 equal 1. So again, this is not equal. So we'll be going in the below loop. So this is x into equal to x. So again, x into equal to x. So 4 into equal to 4, which is equal to 16, x equal to 16. Now we are, this is n equal to n divided by 2. This, now 6 equal to 6 divided by 2, we will be getting like 3. Now we will be doing like, again we will be checking while condition, which is 2. Now checking n modulus 2 equal 1, which is 2, 3 equal 1. So answer equal to answer into x. So right now the answer is 1, and we have x is 16. So 16 will be the answer. And again we will be checking if if it is greater than 0 or not. If it is not, it will be returning the answer. So this way we can solve we can solve this exponential algorithm so problem. And now we have prime numbers. Like, so this is different from the above problem. So here we are not just printing one number is whether prime or not. We are printing the whole sequence from 1 to n. So like we'll be checking, iterating one loop, and we have boolean is prime equal to 2. We'll be iterating another loop to check the prime number or not. If it is prime, we are like checking is prime is equal to false, then we are breaking, and then iterating a loop and printing the value. So this way we can print the prime numbers in easy way. So from this matter we have the time complexity, which is n square. So we can optimize it like using after loop we can iterate till n. So it will be n, and internally we can go till square root of n. So it will be like n of log of n, or square root of n kind of. So this method we have called sieve of Eratosthenes algorithm. So to find all prime numbers up to given number n. So what are the some steps? So this is basically initialization of a vector initially, which is as true, and is 0 and 1 will be false because they are already a prime number. So we have created it, and this is the C process. So when it C processor, it iterated over all the numbers starting from 2 to up to square root of n. Square root of n. Then what it does, if I is prime number, so it check if I is prime, I is true. If it is true, it marks all the multiple of I starting from I into I as false, not prime. So the inner loop marks multiple of I as false, thus efficiently eliminating non-prime numbers. So like this way we can this way we solve this C process. And here we have iteration to print just which are prime numbers. So this way we will be getting the time complexity like with n of log n. So this is the most optimal algo to print a range prime numbers. So these are some questions.